All right, algebraic reasoning. We're going to do this review. It is Western Day. Remember, don't do drugs. Okay, for Red Ribbon Week. So, anyways, on Go Formative, you should have been assigned the Review AR Unit 3 test. Open that up. Cool. So it's 15 questions, and guess what? Your test on Friday is also going to be 15 questions, and it's going to be very similar to this. Now, I got that open over here. That way I can write on it and go from there. So let's talk about this. So the following table can be represented by what type of function? So one second, let me get my. All right, here we go. So it says the following table can be represented by what type of function? So I want us to remember that we've talked about two types. We talked about linear. Okay, so linear is when you're adding each y value, add by the same number, okay? And then you have exponential, which is when you are multiplying the y value each time by the same common ratio. So linear is adding by the same common difference. Exponential is multiplying by the same common ratio. All right. So whenever you have these tables, and this is common difference, and this one's common ratio. All right. So what we're going to do is anytime we see these tables and they're asking us what kind of function is it and how do you know? Well, what we're going to do is first try to find these differences, okay? So what you're going to do is you're going to take your y values and subtract them. What is 5 minus 1? 4. What is 9 minus 5? See how I'm making these bird beaks? I'm going to find these differences. And remember, difference means subtract. So I did 5 minus 1, I got 4. 9 minus 5, I got 4. 13 minus 9, I got 4. 17 minus 13, I got 4. Now, if you're not good at that mental math, that's okay. You can either use your device's calculator, you can use your phone calculator, or you can go to desmos.com and use their calculator, or just Google calculator, okay, for four function adding, subtracting, multiplying, and dividing calculator. So are all these differences the same? Yes, so the common difference is 4. So that means it is linear. Okay? If the common difference is a number that's the same, then that is linear. Now we got to get the right answer here. So look at these answer choices. I see B says exponential. That ain't right. That ain't exponential. D says exponential. That ain't right. Okay, now A and C. A says linear because the common difference is 4. C says linear because the common difference is negative 4. Okay, so it's important that we know whether it's positive or negative. And see how the y values are going up by 4 each time? It's a positive 4. Now I understand how someone can get C. If you start doing if you did for the first difference 1 minus 5, if you switch the numbers, you get a negative 4. 5 minus 9, negative 4. 9 minus 13, negative 4. That's not how it works, okay? The number below minus the number above. The number below minus the number above, okay? It's very important that that's how you do your subtraction, okay? So as the table is going down, is it increasing or decreasing? And in this case, it's increasing. It's positive, so it's A. It is not C because it's not negative 4. And since it's A, it can't be E, none of the above, okay? Cool. All right, so look at number 2. Following table can be represented by what type of function? So once again, let's find these common differences and see if they're the same, okay? So 36 minus 72. Okay, you got a number minus a bigger number that's going to give you negative 36. Okay? And once again, let's subtract. 18 minus 36. Okay, that doesn't match. 3 minus 9, that doesn't match, okay? Now, just because it doesn't match on the differences doesn't mean it's exponential. In the future, we're going to have different ones like quadratic, cubic, quartic. Okay, there's other things that it could be. I know right now we only have two options, linear and exponential, but we want to be careful about that, okay? So that didn't work, right? Now you can either scratch it out or whatever. So it's not linear. But now what we're going to do is we're going to divide, okay? The bottom number divided by the top number. Bottom divided by top. Bottom divided by top, okay? So over here, 36 over 72. Now when I reduce that, I get 1/2. Let's do it again. 18 over 36. What does that reduce to? 1/2. 9 over 18. Oh, I skipped one originally. 1/2. Okay. So through these first three, we get 1/2 as our common ratio. Okay. Here, kind of ignore those last numbers. That is actually an error typo. But so when I did the common ratios, I got 1/2, which is 0.5. So if I get a common ratio, that's exponential. Okay. So this is exponential because it has the same common ratio. When I divide the y values, bottom over top, I get the same ratio. So it can't be A because it's not linear. It can't be C because it's not linear, right? We already said it's exponential. So is it exponential because the common ratio is 2, or is it exponential because the common ratio is 0.5? And we know it has to be D because it's getting smaller, so it's a decimal less than 1, 0.5, right? Again, if you get the numbers switched around, if you do 72 over 36, you're going to get 2, and you might get letter B, and that would be wrong, okay? It's not 2, all right? So again, it's very important that you do bottom over top, or when you're subtracting, bottom minus top, okay? That's the way we do these common differences and common ratios. So since the answer is D, it can't be E. All right. So let's, here, how do we move stuff here? Oh, there we go. All right, number 3, the following table can be represented by what type of function? So once again, we are going to do common differences first and then common ratios. So -5 minus -1 is 4. Sorry, -4. Let me write that. -5 minus -1 is -4. All right, and then let's do the same thing here. We're going to subtract. -25 minus -5, -20. Now, if you find two common differences like that, as long as the x's are increasing by the same amount, if they don't match, then that's not a common it's not a common difference. It's not linear, right? Let's do the math with the common ratios. Let's divide. So -5 over -1 is 5. -25 over -5, well, that's also 5. -125 over -25, that's also 5. So do you see how these common ratios, when you're dividing, gives you the same number, okay? The common, sorry, bad spelling, ratio 5. So that's exponential. All right, so when I divide bottom over top, bottom over top, bottom over top, I get the same number. That's a common ratio. So it's exponential. Can't be B or C because that thing is here. And I know there's a bunch of negative numbers here, but again, when you divide negative divided by negative, you get a positive number. You get a positive common ratio. So the answer cannot be A. The common ratio is not -5. The common ratio is +5. So it eliminates E. Okay. 4, which of the following functions represents the following table? Okay. Now, once again, we want to find out, is this linear or is this exponential, right? So, now just looking at these numbers, they're not decreasing by the same thing, right? So this is, 20. Whoops, not 20. This is going up by 40. This one's going up by 20. It's not a common difference, okay? So when we divide these, -40 over -80, that gives me 0.5. Do it again, bottom over top. -20 over -40, 0.5. -10 over -20, 0.5. So each time I got a common ratio of 0.5, okay? Now, this is where we're gonna have to use what we remember about equations. We did a Desmos interactive activity on this, and we had it at Khan Academy. The formula is y equals a times b to the power of x. Okay, a is your y-intercept. B is your common ratio. Common ratio. Okay. Now, we already found the common ratio, right? We already know our B value over here is 0.5, right? Now, the question is, what is my A value, my y-intercept? So remember, when x is 0, what is y? The y-intercept. Miss Moreira will sing it to you, sung to the tune of Old MacDonald Had a Farm. When x is 0, what is y? The y-intercept. All right, so that means my A value, A, is going to be -80. Okay, so I got my A value is -80, my B value is 0.5. So let's write that equation. Y equals -80 times, I'm going to use parentheses, 0.5. And for it to be exponential, the x must be in the exponent. So don't draw a big X, it's a little x in the exponent for exponential. So which one of these equations has -80 times 0.5 to the power of x in the exponent? Well, obviously, it's just C. Now I want you to notice these distractions. D switches A and B, right? D has the 0.5, the common ratio first, and then it has the y-intercept second. So you can't get that confused, okay? For A and B, well, those are linear equations. Okay, that's mx plus b. That's slope and y-intercept. But remember, there is no slope in exponential. There's a common ratio in exponential, okay? All right, let's look at number 5. Which of the following functions represents the table, okay? So once again, let's see if there's a common difference. Let's subtract first. 15 minus 5 is 10. 45 minus 15 is 30. Can you already see that there is no common difference? It is not linear, okay? So now what we're going to do is we're going to divide to get the common ratio to find the common, we are going to divide to find the common ratio. So let's take these y values, bottom divided by top. So 15 divided by 5 is 3. 45 over 15, well, that also gives me 3. And then 135 over 45, guess what? 3. Okay, so this 3 is my b of my equation. It's my common ratio. Okay, my a value when x is 0, what is y? The y-intercept, 5. Okay, so once again, y equals a times b to the power of x. So my a value when x is 0, the y value we had over here was 5. So y equals 5 times, and then my b value, my common ratio, we circled over here, is 3. So these parentheses, 3. And remember, for exponential, the x is in the exponent. It's a little x up top, not a big X, okay? So 5 parentheses 3 to the power of x. So the best answer is A. All right. Do you see how C has it switched up? It mixed up the A and the B, and then B and D are wrong because they're linear. And we already found out there's no common difference. It can't be linear. Okay. Now, what I've been forgetting to do is put this on Go Formative. Make sure you always put your answers on Go Formative. Whoops. So let's look at what answers did I get for. So I got A, D, D, C, A. So I'm going to go back to the Go Formative. A, D, D, C, A. All right, so I'm making sure I put my answers on Go Formative because that's where I get my grade. And we've done one page. We got 2 more pages to go, so let's take a look at number 6. All right, in the exponential function, f of x equals a times b to the x, or f of x equals a times b to the x. The only difference there is one has a parentheses and one has a dot, multiplication. What does the b represent? Now, we already said this over there, okay, but when you have an exponential equation, a times b to the power of x, yeah, x is in the exponent, right? A is the y-intercept, and b is the common ratio, or you can call it the factor of growth or decay. All right. So again, A is the y-intercept, B is the common ratio, or it's the factor of growth or decay. The growth factor or the decay factor, okay? So when it says what is B, again, we know B is common ratio or the growth or decay factor. So we're gonna pick C. So remember, B, okay, it's the growth or the decay factor. Now, number 7, what does A represent? So remember, A is always the y-intercept, or, and this is true in any graph, the y-intercept is also known as the beginning or the starting value. Cool? So, starting value, you can see that item? Okay, when it's, so yeah, so it'd be letter D, okay? It's not a common difference, it's not a growth or decay factor, that was B, and it's not the x-intercept, that's for sure, okay? So make sure you know what A and B stand for using this terminology, okay? All right, 8, in the exponential function, what type of function results when B, now, this means, what does that weird stuff mean, okay? That means B is between 1 and 0. So that means B could be what, like 0.1, 0.5, 0.97, anything that's less than 1 but greater than 0. And that's going to be a decimal or a fraction, okay? So when you think of less than 1, you should think less, you should think small, you should think dk. Decimal, less than 1, dk. Okay? So again, decimal, less than 1, dk. Cool? There's your hint. Decimal less than 1 is dk. So this is going to be called exponential dk. Now what about if it says b is greater than 1? Greater than 1. Great. Oh my gosh, hold on. Yeah. Greater than 1 is growth. Greater growth. Cool? So if it's greater than 1, the b value, you know you're going to have exponential growth. That should be letter D. Okay? So that should be, and it's going to be very similar to that on your test. So again, decimal, but less than 1, dk. Greater than 1, growth. Cool? All right, number 10. What is the difference between a linear and an exponential table? Now, we did this on numbers 1, 1 and just looking at number 1 and 2. Linear had a common difference, right? And then exponential had a common ratio. So let's try to think about this. On an exponential table, it says linear only increases, exponential only decreases. So I want you to know, linear and exponential both can either increase or decrease. That ain't right. Exponential only increases. Right, okay? So linear and exponential both increase and decrease. All right. Now, I think these are mixed up. Dang it. Well, I'm sorry about that. See, this one's asking really about the graph, and then this one's actually asking about the table. Whoops. Okay, well, anyways, looking at, when we think about the graph, remember linear is a straight line, exponential, so linear looks like this, straight line. Exponential looks like this or this, right? Curved. So linear is curved, nope. Exponential is curved. And then linear is straight. Cool. So 11, what's the difference between a linear and an exponential graph? Table, sorry. Linear has a common difference. Okay. So we remember linear does have common differences. That's right. Exponential has common ratios. Hey, that's right. I like it. B is wrong because it says exponential has common differences. Linear has common ratios. That's not right. And then remember, we already said linear and exponential both increase and decrease. So 11A is right. C and D are not. All right. So once again, I need to put this on Go Formative. I've been slacking. So what did we get here? CDC, DDA. Let's make sure I got that right again. CDC, DDA. Cool. Last page. We just got 4 graphs. Let's get it. Which function matches the following graph? All right. Well, let's remember y equals a times b to the x. Remember, a is the y-intercept, b is my ratio, okay? So on all these, a should be the easiest one, okay? So on your y-axis right here, where is the y-intercept? That's my a value. So my a is 3, right? That's where it crosses the y-axis. Okay, now my b, what I'm going to do is I'm going to need to divide to the, let's see here, common ratio. I'm going to take this y value right here, over this y value right here. So 6 divided by 3. Do not subtract. Remember, subtraction is linear. We are dividing. 6 divided by 3 equals 2. So my b value is going to be 2. All right? So my a value is 3. My b value is 2. So it's going to be 3 times 2 to the power of x. And you can see how letter D is a distractor because it's switched around. You can see how letter B is a distractor. If you subtracted 6 minus 3, you get 3, but we're not subtracting for exponential, we are dividing. And how do we know these are exponential? Look at their curve, okay? That is not linear, okay? So far, we're just doing exponential. This is the exponential test, right? So I want to know that you can do that. Which function matches the following graph? Okay, so once again, we're doing y equals a times b to the x, right? So once again, on the y-axis, you go down here. What's this y? This a equals 1, right? That's where my y-intercept is. All right. And then for my common ratio, I'm going to do division. Okay. So I'm going to take this y value, which is 7, over this y value of 1. 7 over 1 is just 7, right? So my b value is 7. So my equation, a times b to the power of x is 1 times 7 to the power of x, which is letter A. C is not right. It is switched around. It's wrong. And again, D is not right because you're not subtracting. You are dividing for a common ratio. All right. What about 14? What's my A value here? So my A value is 2. And then for my common ratio, I'm going to do 8 over 2, which is 4. My B value is 4. So I'm going to have 2 times 4 to the power of x. All right, remember, common ratio. Oops. All right, last but not least, number 15. What's my A value? 2. And I'm going to divide these y values. I'm dividing because it's a common ratio. So this is 4 over 2. 4 over 2 is 2. So B value is also 2. 2 times 2 to the power of x. It's going to have to be B. All right. Your test is going to be very similar to this review. You want to make sure that you understand this review. You might want to go over the video again. Make sure you've done all your Khan Academy stuff. Retake it until you get passing grades. Make sure you prepare well for your test on Friday. It's very similar to this review. All right? You go ahead and have a good day now. We'll see you.